Okay. Question of the day goes to Chrissy Munson. Tyler, do you have these notes? You don't. So, well, I'm wondering, do you have a section that says 3.3 derivative? Okay. All right, so here we go. So to Chrissy's point, she says, what if we have a quotient? How do we handle that type of situation? Well, first of all, you can express it as a power if we would like to, but let's suppose that you have something that looks like this. Let's say you have, let's suppose that you have f of x is equal to x minus 3 over 4 minus x squared. Let's suppose that that was your function. Could you find the derivative of that? Well, in fact, we can. The derivative is going to be, and again, this is f divided by g. We take the derivative of the top times the bottom left alone minus the derivative of the bottom with the top left alone, and we divide it by the bottom left alone squared. If you want to see the proof for it, check out your book or stop by after class. And you guys trust me. They last year they had no problem with getting these after a while. You're going to use these a lot. And but the same can be said about a product function. And it's hard to give a good example of this to you right now because you don't know trig yet. But let's suppose that our function was f of x is, say, e to the x sine of x. Then it's like, well, those are two functions that you multiply together. So, how can you find the derivative of that? Well, it's very similar. It's f prime times g plus g prime times f, and that's it. And so we're going to practice that today. We're going to practice it. What? Okay. Let's flip it over. We did all of those, so we go to the next page. I apologize for the terminology here, you guys. What I'm going to say is, that this is f of x. So I should really use something different to label the top and the bottom other than f and g. So just for the sake of clarity, you don't have to do this, but technically, this should probably be something like, say, h of x. And I'm not going to do that for everyone. I'm just going to get that out of the way right now. So f is what's on top, g is what's on bottom. Are you going to use the product rule or the quotient rule? The quotient rule. And what the quotient rule says is that, so we'll say h prime of x is equal to, what is the derivative of the top? 2x times the bottom left alone, x minus 1, minus, what's the derivative of the bottom? 1 times the top left alone, x squared, divided by the bottom squared. And always leave the bottom expressed as a square because you might have a chance for something to factor out. That's it. That's all we do. Now we just simplify the top and we look to see if something would cancel. So let's look at the top here. I've got 2x times x minus 1, which would give me okay, and so I have a 2x squared and a minus x squared that will reduce to x squared minus 2x over x minus 1 quantity squared. Now, the top would factor to x times x minus 2, right? Would that cancel with anything in the denominator? No, so we leave it. So that's our derivative. We're done. But notice, in order to find these derivatives, what we're doing is we're actually taking the, we're actually using the power rule that we used before. Are there any questions on that first one? Okay. Now, again, you guys, I need you to understand this. Okay, I need you to understand this. If you were actually going to find the derivative, you would just FOIL this out, right? Okay, but realize that later on, this is what I'm going to give to you instead. I'm going to give you h of x is, we'll do something like, say, x squared sine of x. And you got to be able to find the derivative of that. And that's not something you can FOIL out, but that involves a product. Two functions that are multiplied together. Chris, you had a question? Exactly. So this is my function, and now that I found the derivative, I could find the slope, instantaneous rate of change at any given point by simply plugging it into here. That's why we're doing this. Yes. Chrissy brings up a very good point. It's been a while since we got back to that kind of, why are we doing this? Instantaneous rate of change at a given point for any value of x. Okay. So, let's do this. H prime of x. H prime of x. You take the derivative of the first, which is 4x times the second one left alone, right? Which is 5x squared minus 2x plus the derivative of the second, which is let's just leave that, okay? We're not here to practice algebra. We're here to practice the rule right now. I know you guys can FOIL that out and combine like terms. Last year I did. Last year there were certain problems. There are certain problems. Not on the worksheet I just gave you. The worksheet I just gave you, those derivatives, they need to match up. But on this portion, again, I'm more concerned that you can find the derivative of that one. Because I know that you guys would probably just FOIL this out. That's what I do. I wouldn't use the product rule there. But we're at that point in the book where it wants you to practice that. So, we're going to practice it like that. But for this section, Tyler, we're going to make sure that you guys can try the rule properly. C. This is a trick question. It does work. Don't in this situation right here, don't use the quotient rule. Just this is f of x is going to be I'm not dividing or I'm not canceling parts here. I'm simply going to divide each term by the denominator. What's square root of x divided by square root of x? 1. Minus what's x to the 1 divided by x to the 1/2. No. Here, you guys, here's what Ina did. Ina did 1 divided by 1/2, which is 2. She's exactly right. But you should subtract your exponents. So this simplifies to that. And so now we take the derivative. Kelly says no. X to the 1 over x to the 1/2. Right, Kelly? Do you see it? Square root of x divided by the square root of x is 1? Minus, then I have x to the 1 over x to the 1/2. No. Okay. How about this? It might be. I'll show you what reducing parts is. Okay, here's reducing parts, saying that is equal to 1 minus x. That's reducing parts, because what you did there is you canceled that off. You can't do that. But I divided each one. Here, I'll try it one more way and see if you guys like this better. F of x is equal to, I'm going to factor out a square root of x, and I'm going to be left with 1 minus the square root of x, all over the square root of x. How about that? Do you like that better? So now if I take the derivative, what's the derivative of 1? 0. What's the derivative of negative square root of x? Yep. Good job, Ina. Okay, the next one is the quotient rule, and maybe, or I'm sorry, product rule. Maybe instead of actually foiling all this out, or distributing all these terms, I should say, maybe instead of doing that, you would actually, actually use the product rule. So let's give it a shot. Shh, boys. What's the derivative of square root of x plus 3? Okay, so square root of x is x to the 1/2, right? If you take the derivative, you get 1 over 2 times x to the negative 1/2, which is 1 over 2 square roots of x. Over here? Yeah. Okay, times the second one left alone, which is x to the third minus 2x plus 1, plus what? 3x squared minus 2 times the square root of x plus 3. Let's just leave it like that for right now, okay? No worries. That's a derivative. If you plug in x there, you will get the instantaneous rate of change at a given point. We're almost out of time. We gotta hustle. Okay. Yep. I have an advisory, yep. How about this? Should we pick these up you have a work day tomorrow. Let's do these 2 tomorrow. I'll give you your assignments so you can work on that tonight, and we'll go from there, okay? Let's do that. We'll get to that tomorrow too. So your work day. So you guys, when we get to class, I'll be ready to work right away so you can get to your work day.